All right, so in this lesson, we're going to multiply numbers that are written in scientific notation. So for example, in the first one, we have 2.6 times 10 to the negative fifth. So this is a number in scientific notation. And then that's going to be multiplied by 4.8 times 10 to the negative 6. So see, I have two numbers, and both of those are written in scientific notation. Now remember, make sure you understand or you recall what makes a number uh, written in scientific notation. So I'm going to go ahead and cover this one up. So you see this number here that's in scientific notation. So you see this, the coefficient. Remember, that's called the coefficient. This is the base. The base is always 10. And then you have your exponent, which is an integer. So in your coefficient, there's only one non-zero digit in front of the decimal point. So this can be 1, 2, 3, all the way to 9, right? So any the one digit you see here, that ones place right here of the coefficient has to be 1 up to 9. All right? So it can be only one digit. So that makes this number scientific notation, and the same thing here. So what you want to do here is to regroup. See, all these are multiplication. 2.6 times 10 to the fifth times 4.8 times 10 to the negative 6. So you have all multiplication going on. And remember, multiplication is commutative. So the order in which you multiply does not matter. So then what I'm going to do then is I'm going to group the coefficients together. So I'm going to say, well, that's going to be 2.6 times 4.8 in parentheses. So I'm grouping the coefficients. And then I'm going to group the powers of 10. So I have 10 to the negative fifth times 10 to the negative 6. Okay? Now let's go ahead and multiply the coefficients out. 2.6 times 4.8. So 4.8 times 2.6. So 8 times 6 is 48. So 8 carry the 4. 6 times 4 is 24. Plus 4 is 28. And then we go to 2. 2 times 8 is 16. So put the 6 here. Carry the 1. 2 times 4 is 8. 8 plus 1 is 9. And then we add them. So that's 8. 8 plus 6 is going to be 14. 9 plus 1 is 10. Plus 2 is 12. So I get 100, oops, sorry, 2 decimal places, right? So that goes right here. So I'm not sure where the decimal point came in. So 2 decimal places, so that's going to be 12.48. So this right here is 12.48 times. And then remember your product rule. So the product rule for exponents. So when the base is the same, when you're multiplying like bases, you add those exponents. So the product rule for exponents. So the bases 10 are the same, so basically going to add those exponents. So what that becomes is this. I'm going to go ahead and write it like this. So it'll be 10 to the negative 5 plus negative 6. So you add exponents. When you multiply like bases, you learned that in the previous lesson. When you multiply like bases, you add exponents. Negative 5 and a negative 6. So it becomes 12.48 times 10. And then negative 5 and negative 6 is a negative 11. All right, so that's where I'm at. Now remember, to get this 12.48, I had to multiply, right? So be careful when you multiply. Some of you could put the digit in the wrong place, could multiply incorrectly. So you have access to calculators. So double check. Double check to make sure that's what you have. So look, 4.8 times 2.6, right? And so you get 12.48. Right here, negative 5 plus a negative 6 equals negative 11. So always double check your work. You have access to a calculator. All right, now here's the issue we have now. This is not in scientific notation because how many digits rather are in front of that decimal point? So here's my decimal point. There are 2. Remember, a number written in scientific notation, that coefficient must be between 1 and 10. Okay, so it has to be less than 10. So that can only be one digit in front of decimal point. So you see A here, 12.48, is not less than 10, right? That's greater than 10. So then we got to think about this 12.48. So what I got to do now is take this 12.48 and put this in scientific notation. I've got to put this in scientific notation now. All right, so let's just remind ourselves how to do this. So I'm going to take this decimal point, I'm going to move it to the left. So you got to move it to the left because you want only one digit in front of that decimal point. So since I moved to the left, so I moved to the left one place, right? So then this becomes 1.248 times 10 to the, and remember I moved it one place and put a 1 here, and then think, is this going to be a positive 1 or a negative 1? All right, so if it's a positive 1, what that means is what I just wrote, the scientific notation, what I just wrote, this scientific notation has to be greater than 1.248, and it is. So this number here is greater than 1.248. 12.48 is greater than 1.248, and so 1's correct. So then this becomes this now. So this becomes this becomes 1.248 times 10 to the first, but don't forget we have 10 to the negative 1 up here, times negative 11 rather, 10 to the negative 11, and then we use the product rule again. 10 to the first times 10 to the negative 1. I'm multiplying like basis, so I add exponents. So this becomes 1.248 times 10 to the first plus a negative 11. 1 and negative 11 is a negative 10. So I get 1.248 times 10 to the negative 10th power. And that's the answer. So now this product right here is now written in scientific notation. All right, so make sure you go through the processes again, all those steps. So let's look at number 2. So number 2, I'm going to do another one. And number 2, we have 7 times 10 to the negative 8 times 4.3 times 10 to the 5th. So I have these two numbers in scientific notation. That's a decimal point right here. And I want to multiply those two numbers out. So I'm going to group the coefficients, and then I'm going to group the powers of 10. So I'm going to group the coefficients. I get 7 times 4.3. And then when I group the, so we times, and then the powers of 10. So times 10 to negative 8 times 10 to the 5th power. So let's go ahead and multiply the coefficients out. So 4.3 times 7, right? 7 times 3 is 21. Carry the 2. 7 times 4 is 28. Plus 2 is 30, right? One decimal place. So I get this. So I get 30.1. And double check. So 7 times 4.3 equals 30.1. So it becomes 30.1 times. Now remember, you're multiplying like bases. So the product rule, right? The product rule. So when you multiply like bases, the product rule for exponents, you add those exponents. So this becomes 10 to the negative 8 plus 5. Well, negative 8 plus 5 is negative 3, so this becomes 30.1 times 10 to the negative 3rd power. But remember, this part right here is not in scientific notation, because how many digits are in front of this decimal point? There are 2. That can only be 1. Remember, this coefficient has to be a number between 1 and 10. Well, 30.1 is not less than 10, right? Okay, so we got to move this decimal point. So let's play around with 30.1. So I got to rewrite 30.1 in scientific notation. So I'm going to move that decimal point to the left until there's only one digit in front of that decimal point. So 30.1 is equal to 3.01 times 10, and then how many places did I move it? I moved it one place. Is it a positive 1 or a negative 1? Well, if I keep it as a positive 1, this means that this number that's in scientific notation, that means that this number that's in scientific notation has to be bigger than 3.01, and it is. Okay? All right, so then this becomes right here, 3.01 times 10 to the first times 10 to the negative 3rd. Then we go ahead, we have one more step to do. We simplify this little part. So I'm multiplying powers of 10, right? So when you multiply, like bases, When you multiply like bases, you add exponents. So the product rule, multiply like bases, add exponents. I get 3.01 times 10 to the first plus a negative 3. 1 plus a negative 3 is a negative 2. So I get 3.01 times 10 to the negative second power. All right, and so that's it. So that is your answer. So there's your work, and there's the answer. Now, you can always check this real quickly. Now remember, this is your work, right? That's your work. So if you ask to show the work, make sure you do this. But let's just remember that when you multiply two numbers in scientific notation, all these are products. So the order in which you multiply does not matter. So that's why we regroup. So I'm putting the factors, the coefficients together, and I'm putting the powers of 10s together. So the order in which you multiply does not matter. But if you go back to the original, we have 7 times 10 to the negative 8, right? Times 4.3 times 10 to the 5th, correct? And then I get 0.0301. And then notice, remember this is 0.0301, right? So is this right here that I have boxed off, is that the same thing as this? Yeah, it is, because remember what negative 2 does. So negative 2 would mean I move the decimal point to the left 2 units, 1, 2. So I have 0.0301, which is what you see there. All right? Okay, that was number 2. Let's look at number 3. Okay, so number 3, I want to multiply these two numbers that's in scientific notation. And so remember, this when I read it, this is read as 4.6 times 10 to the negative third times 8 times 10 to the negative 6. So it's all multiplication. And so since it's all multiplication, remember multiplication is commutative, meaning that the order in which you multiply does not matter. So if I want to put the coefficients first, I can. 4.6 times 8. And then times. And then if I want to group the powers of 10, I can do that as well. 10 to the negative third times 10 to the negative 6, because all of this is multiplication. The order in which you multiply does not matter. Now, let's go ahead and multiply the coefficients together. 4.6 times 8. 8 times 6 is 48. Carry the 4. 8 times 4 is 32, plus 4 is 36. 1 decimal place, right? So I get 36.8. So this is 36.8. And then you can always verify 4.6 times 8. 4.6 times 8 is 36.8. So I get 36.8 times, and remember the product rule, the bases are the same, so you multiply like bases. When you multiply like bases, you add exponents. So it'll be times 10 to the negative third plus the negative 6. And a negative 3 and a negative 6 is a negative 9. So it becomes 36.8 times 10 to the negative 9. But remember, this number is not scientific notation because there are 2 digits behind the decimal point. So then I have to go to the side and think about what this equals in scientific notation. So 36.8, I'm going to take this decimal point and move it to the left until there's only 1 digit in front of that decimal point. So this becomes 3.68 times 10. I moved it 1 place, so I'm going to put a 1 here. And then do I keep it as positive 1? And the answer is yes, because this number here that's in scientific notation has to be bigger than, since that's positive right here, positive 1, has to be bigger than 3.68, and it is. Okay, so 36.8 is bigger than 3.68. So then this becomes 3.68 times 10 to the first times 10 to the negative 9. And then using the product rule again, product rule for exponents, when you multiply like bases, you add exponents. So this becomes 3.68 times 10 to the 1 plus a negative 9. 1 plus a negative 9 is a negative 8, so I get 3.68 times 10 to the negative 8th power. All right, and so that is your answer in scientific notation. Again, just as quickly check this. So let's check this real quickly. So I'm going to use, remember this is your work, so if you ask to show the work, you got to show all this now. Okay, so 4.6 times 10 to the negative third, negative third, times 8 times 10 to the negative 6. So you see, get this right here, right? So look, if I take this decimal point and move it to the right, I go 1, 2, 3, 4, 5, 6, 7, 8. So I get 3.7, right? So it's times 10 to the 8th power, which is what this is. To the negative 8 since I moved it to the right. Now you may say, well, that's a 7, not 6.8. That's because your calculator can only display so many digits. So that's why you got to be careful when using your calculator. You know, it can only display so many digits. All right, so be careful when using a calculator. So if you put 3.7 times 10 to the negative 8, that's incorrect. That means to me what you did was you did not do any work. All you did was go directly to your calculator. So you got to do the work and then use your calculator to help you to see if what you have is correct. So I know what I have is correct in terms of that exponent because I moved it 8 places, 8 digits to the right, which makes it negative. All right, so that was number 3. And then if you just look at that 4.6 times, this is kind of, show this again, times 8. See that 36.8? So you know that this had to be 3.68, right? Okay, so 3.68. Okay, number 4. Number 4, we have this problem. We have 3.7 times 10 to the 5th times 7.8 times 10 to the negative 9. Okay, so I have these two numbers in scientific notation I'm multiplying together. So all this is multiplication. So the fact that it's multiplication implies that I can regroup because multiplication is commutative. The order in which I multiply does not matter. So I'm going to put all of the coefficients together, and I'm going to put the powers of 10 together. Now 3.7 times 7.8, I'm going to just quickly use the calculator here because of our time purposes. 3.7 times 7.8 is 28.86, right? That's 28.86 times. And then when I multiply like bases, a product rule, I'm using a product rule for exponents. That's what I'm using, product rule for exponents. You learned that in the previous lesson. When you multiply like bases, you add exponents. So this becomes 10 to the 5 plus a negative 9. 5 and a negative 9 is a negative 4. So if you got to use your calculator to figure that out, then make sure you do that. 5 plus a negative 9 is a negative 4. So it becomes 28.86 times 10 to the negative 4th power. Well, remember, this is not scientific notation because this number here, this coefficient, it has 2 digits behind that decimal point. That number is greater than 10. Remember that coefficient has to be between 1 and 10. So it cannot be greater than or equal to 10. So that means that 28.86, I've got to rewrite and change that to scientific notation. So 28.86, I move the decimal point 1 place to the left to get 1 digit here. So it becomes 2.886 times 10 to the 1st power. So this becomes 2.886 times 10 to the 1st times 10 to the negative 3rd. And we go to the process again, multiplying powers of 10. So these are like bases. I'm going to add those exponents. So that's 2.886 times 10 to the 1st plus a negative 3. 1 and negative 3 is a negative 2, and there's your answer, 2.886 times 10 to the negative 2nd power. All right, so that's number 4. Let's do one more, and this will be number 5. So that's the last one we're going to do, and I think that will have given you enough examples to be able to do the assignments with that section. Okay, number 5, we have 4.3 times 10 to the negative 3rd times 2.6 times 10 to the 8th. All right, so these are two numbers written in scientific notation. And so since this is all multiplication, I know that multiplication is commutative, so I can put the coefficients together, and then I can put the powers of 10 together. So 4.3 times 2.6 times, and then powers of 10, 10 to the negative 3rd, times 10 to the 8th. All right, so let's do the coefficients. Let's use a calculator. 4.3 times 2.6 equal, and that is 11.18 times. And then I know that using a product rule, when I multiply like bases, I add exponents. So that's 10 to the negative third plus 8, right? So it becomes 11.18 times 10, and then negative 3 plus 8 is 5, correct? All right. Now, but remember, this is not scientific notation because this coefficient. This coefficient here has to only have one digit in front of the decimal point. It has 2. So let's talk about how to rewrite this. So 11.18. Okay, so I'm going to take this decimal point and move it one place. That's all I need to do is one place to get one digit in front of the decimal point. So this becomes 1.118 times 10 to the first power. And so I get 1.118 times 10 to the first times 10 to the fifth. And you see the powers of 10 again? So I know that the product rule for exponents says when I multiply bases, I add exponents. So this becomes 1.118 times 10 to the first plus 5. 1 plus 5 is 6, and there's your answer, 1.118 times 10 to the 6. Okay? All right, so that is the lesson on multiplying. So in this case, if you look at, go back on all of the problems we did, we multiplied numbers and we wrote it in scientific notation. All right, so that's the end of this lesson.